Hello students, hope you all are doing well, and as this unlock frees more, you are also studying more and more. We are just hoping for that. Alright, welcome to this video. So today we'll be going for the next concept called as measures of dispersion. So before we go for measures of dispersion, a quick recap what we had spoken about in the previous couple of videos regarding measures of central tendency. So we started with arithmetic mean, then the median value and modal value, all these three, and we also spoken about the quartiles, which makes the standard partitions in the entire distribution. So these are the partitions along with the central values, these modal values. These all values tells you about how this distribution is dense at the central part and what is that value which is representing the entire distribution. Have a look on this. So suppose these are the two frequency curves I have drawn. So this the higher one, so this is one frequency curve and this is one with not with higher value, but both of these curves are normalized. I mean this curve, let me call it as frequency curve F1 and this is also frequency curve F2. So this F1 and F2 both are like increases in the beginning, then reaches the maximum point and then again decreases. So both of them are normalized, both of them are into normal pattern. So in this way we really expect that the arithmetic mean value would be in the central part. So in the case where we have still normalized curve but inclined towards right or towards left based on their frequency. So for example, if the shape is like this or if the shape is like this. So it is still again increasing, then the maximum value and then decreasing. So in this case, due to the central tendency or due to the concentration of the elements, the arithmetic mean also fluctuates. So this is because of the values or this is because of the frequency range. So now in this case, both of them are normally distributed and they have equal number or similar number of distribution on their both the sides. So you may really expect that their arithmetic mean would be at the central, and for both of them we get the arithmetic mean at the same point. So this is what the arithmetic mean tells. So it's not only arithmetic mean which is at the center, the modal value as well as the median value, those two values are also in the central part. So what or you can say, so these all three, that is the arithmetic mean, median and mode, these all three are telling you about the central part of the entire distribution. That's why they are called as the measures of central tendency. So now in these two examples, both of them will have all these three values near to this particular point. But what is the difference between their distribution? So now the frequency curve F1 is having the smaller dispersion or you can say the smaller range as compared to frequency curve F2. So F2 is starting right from the origin of the x and y axis and then spreads little more as compared to F1's range. So the spread of F2 and F1 is different, but their central tendency is same. So now you are coming to understand that central tendency will not concentrate on the spread at all. The central tendency tells you only about the central part of the distribution where most of the items or at least 50% of the entire distribution is concentrated or dense. So there is the range where we get the modal value, we get the median value as well as the arithmetic mean. So these all three values fail to measure the range or you can say the spread of the distribution. So this is one such example. So the spread of these two frequencies are different, but their central tendency is similar. So central tendency, these three measures will not tell anything about this spread. The arithmetic mean still gets fluctuated due to too high or too small values, that is true. But considering the entire spread of the frequency, central tendency measures are not helping much. So here we have to look for the measures of the dispersion. So we'll be discussing about the measures of the dispersions today. So beginning with the first one, measures of dispersion. So the first range, the first measure of dispersion we'll be discussing today is the range. So the range is, so now this particular thing is called the range from this to this. And for this to this is the range of F1 and this is the range of F2. So the range tells the spread, the starting point and the last point. So this is what the range tells. You can consider it as width also. So in the group data, how we have the width of each class. So width of the entire distribution is nothing but the range. So basically range is the difference between the largest element in the distribution and the smallest element in the distribution. This is what the range tells. So this range gives you the spread of the entire distribution, but then again range will actually not tell you how dense the elements are or what are the distances between them, what are the deviations between the elements in the distribution. It tells only about the width of the distribution. So in that case, if we have two such measures, that arithmetic mean of this and this, then if you know the arithmetic mean as well as their range, then there it makes you to understand in such a wide range the arithmetic mean is this. So that makes you to understand that elements or the items in the distributions are much deviated, or there is a good spread, or there is a large spread among all of them. In the case of F1, if the range is known and also the arithmetic mean, so compared to the range, the arithmetic mean, that makes you to understand whether the elements are too away from each other, or they are dense, or they are still normal. Normal in the sense they are not too away or they are not too dense. So considering these two at a time, that will make you to understand how the elements are distributed in the entire distribution. So this is how range will help you to understand the spread, and along with the spread, if you have the measure of central tendency, then that will make you to understand the entire distribution in two ways. Alright, so we'll take one example for range. So the example is here. There are four workshops, and the productions details are here. So these are the ranges from 15 to 36. Okay, then for A, the 10 values are between 21 and 22. 22 values are there between 23 and 24, and this way. So the class range is hardly just of width 1, but it is, you can have a look at the limits of the classes here. So it is 21, 22, and then it is 23, 24. So these are the exclusive classes. Exclusive in the sense their limits are totally different. We are not including the upper limit of one class as the lower limit of the next class. So this is called as the exclusive class. So in which both of them are considered. So for the exclusive class, the width is here, though the difference is 1, but the width is actually 2. Because here these both the limits are considered when it is exclusive class, and if it is inclusive class, we will either exclude the upper limit or the lower limit. Okay, so now the example is given in such a way that total of items in all four series all four frequencies you can say is 80, and also the arithmetic mean for all of them is 25.5. Okay, so it's the same thing that we were talking about. If we have the frequency patterns in one particular way, that they are completely normalized in such a way that all of them have the normalized point, or the point where we have dense data at the same point. So this, because of that, all of them are having the same arithmetic mean. But if you look at the values here now, especially for A, there we have only 6. It comes into only this part. So the frequency pattern is only for these classes. So it has got the smaller spread, or among all of them it has got the smallest spread. So this is how about A is given, then for B, C and so on. So this is how the elements are dispersed as per the classes. Okay, so now we have to calculate the range for each of it. So basically range is the difference between the smallest and the largest element. So for range, or you can say the difference between extreme values. So for range of A, so basically range is given as the difference between their extreme values. So for A, range will be calculating. So now the 10, 22, 20, 14, 14 are the frequencies. So these frequencies are relating with this class. So in this class 21 is the minimum value and 30 is the maximum value. So for range of A is 30 minus 21, which is 9. So similarly we have to calculate the range of B as well. Minus 17. Is the range of B. Now look at C. C is starting from the first class, and here from the 35 to 36 there are no values, but there are some values from 37 to 38. So what happens? C covers all the classes right from 15 to 38. So the range of C would be 38 minus 15, which gives you 23. Similarly, the range of D is from this class to this class. So it is 19 is the minimum value here and 34 is the maximum value. 15 again is the range of D. So this is what the range tells you. It is just the difference between the extreme values of the distribution. So now what this value tells you? So it tells you the spread of the entire distribution. So now only spread of the entire distribution will not give you much idea about how items are distributed among that spread or among that range. So now looking at 9, what you can understand is that at the 9 scale all the elements are dispersed. But how those elements are dispersed, or are they distributed uniformly, or they are concentrated at one part and other parts it is just distributed, or they are concentrated at two parts, So there is no information regarding this. This range cannot tell you about. So range can only tell you about the scale in which the entire distribution is fitted, or all the elements of the entire distribution are in between this range or on this scale. This is what the range tells you about. So now we have one more coefficient or one more measure related to range. So that will be calculating. That will give you little idea about how elements are dispersed. So that is, so to understand or to have an idea about how the elements are dispersed among this entire range, we have one measure called as relative dispersion. So relative dispersion is the ratio of range divided by sum of the extremes. Range is nothing but the difference of the extremes, and that we are dividing by the sum of the extremes. So for example, for A, the relative dispersion would be range we have already calculated as 9 divided by their sum of the extremes, which are 30 and 21 together, it is 51. Okay. Then for B, the range we have calculated as 15 and sum of their extremes gives you 49. Then for C, so these are the relative measures we have calculated. This is 9 by 51, 15 by 49, then 23 by 53 and 15 by 53. Okay, so now if you consider, if you look at their values, now 9 divided by 51 and 15 divided by 49. So if you want to compare these two are comparable because they have same denominator. But comparing these two, now this denominator and this denominator is different. But then again, this 9 is much smaller than 51 as compared to 15 and 49. So among these all, this would give you the smallest value. Okay, and these two are having the same denominator. So 53 is the highest denominator. In that, this is having the lower numerator compared to this one. So this will give the highest value among all. The meaning of this is this here will have the minimum value among all, or minimum dispersion you can say. And here you are going to have the maximum value. That is the maximum dispersion. So now what is the meaning of these two? So the first one which says there is a minimum dispersion, that means as compared to the number of elements in this particular workshop A or the frequency curve A, they have, compared to other B, C, D, they have minimum deviations among them. That is the meaning of it. I mean, there is a minimum dispersion. They are not much away from each other as compared to their ratio value. Where in this D, which is having the maximum value among A, B, C, D. So as compared to A, B, C, D is having the maximum dispersion, or the elements are dispersed away from each other as compared to A, B, C. Now, anyways, we have got the frequency pattern here. So if you look at the frequency pattern, look at this. 10 is the minimum frequency at one particular 23, 24. Then 25, 26 is having 22, and then another is having 20. So these two, I mean 25, 26 and 27, 28. These two are having most of the part, that is 22 and 22 together, 42 elements of the 80. So 50% of the elements are near to each other, and other 50% are again beside it. So here there is a minimum dispersion, and the same value we get it here for the minimum dispersion. Then if we compare this D, we have four elements in the range 21 to 22. Then we have 14, 16, 16, 12, 12. So it is again in the similar values 14, 16, 16, 12, 12. And then we have 4 and 2 at here. Okay, but if we compare this C, which is actually having very dispersed values like 2, 4, 6, I mean, if you consider till here, and then this is blank, and again there are 4 more elements. So among 80, so this is how it is much dispersed. So C is having actually the more dispersed data as compared to A, B and D. Okay, so now this one is one, what do you say, the exception here, that even the relative dispersion is failing to explain. Now this is happening because of this absence of one particular range, and after that range you have got 4 more elements. There is a cluster of 4 more elements after skipping one particular range. So in that case, when we have distribution in this way, that relative dispersion also may not tell you about how exactly the elements are dispersed. So as long as we have the continuous dispersion, whether it is a heap curve or it is a slightly bent curve or it's a normal curve, relative dispersion will still help you to find or to know about their dispersions or their dispersions among themselves. But in the case we have some extreme values or some values with skipping some class intervals in this way, relative dispersion may not actually help you to understand their dispersions or deviations among the elements. So this every such measure has their advantages and disadvantages. So initially we have learnt about the central tendency. So now we are looking for this relative measure. I mean, we are looking for the measures of the dispersions. So basically range tells you the spread of the frequency, spread of the distribution. That will not tell you about how elements are dispersed, but to know that we can have a look on the relative dispersion, that will tell you about only the less and more dispersion, how close they are or how away they are, considering all of the distribution. And there also it fails if there are higher values or smaller values, or if the range is such a way that there is a large part on one side and again there are other extreme parts on other sides. So in that particular distribution, relative dispersion will not actually tell you about the dispersion of the elements. So this dispersion is, we have to take into consideration the whole distribution, and then that will help us to know about whether the elements are dispersed at the uniform, or they are concentrated at some points, or they are concentrated only at one point. So these all things. So this is what the measures of dispersion tells you about. So this is all about range. Now we'll move for the next concept, which is called as quartile deviation. The next measure of dispersion is quartile deviation, and quartile deviation is given by the third quartile and the first, the difference between them divided by 2. So for any normal frequency, at the central part we have the median, or you can say the quartile 2. and the one which is making 25, 75 will give you quartile 1, and vice versa will give us the quartile 3. Okay, so then what quartile deviation is telling exactly? Only between the central part. It's not the central part which is regarding only with the measures of central tendency. So the central part, it's not only about the arithmetic mean or median or mode. Also considering the other two parts, again the larger central part, so that is in between quartile 1 and quartile 3. So the quartile deviation is mainly focusing on this part. So where we have, what do you say, the highest frequency or the higher frequencies of the entire distribution, when it is in the normal form, there is where we have all or the most of the higher frequencies here. So these two parts, I mean this part, the extreme parts or the extreme ends are dropping much or are dropping at the greater level. So the quartile 1 and quartile 3 and the dispersion between them covers the central part which is having the most of the items in the entire distribution. Now if the distribution is very much normally curved, then you can still say that the 50% of the items would be around the modal value of this distribution. So then again considering the quartile 1 and quartile 3, in the case of the normal frequency, they can still cover nearly 70% of the entire distribution. And this deviation, this quartile deviation, what that ratio gives you, that will tell you about the disperse or the distances between the elements, how they are deviated from each other. So along with quartile deviation, we also have quartile coefficients. So quartile coefficient is nothing but the differences of this quartile and their addition of this quartile. So quartile deviation is given by this way. It is the ratio of the differences of the quartile to the addition of the quartiles. This is what the quartile deviation tells you. So hope you have got this. So how to calculate quartile deviation is this difference divided by 2, and the coefficient of quartile deviation is calculated in this way. So let me take one example for this. So we'll solve and we'll also calculate both of them. The given data is this way. Class intervals are given along with their frequencies. So we have to first calculate quartile 1 and quartile 3, and we know that we have to calculate the indices of 1/4 and 3/4. So let me first calculate the total of these frequencies along with their cumulative frequency. So this gives me 83. So let me also calculate the cumulative frequencies. So cumulative frequency less than, it matches tallies with the total. We can go ahead with this. So n by 4, that is the 83 divided by 4 gives you 20 point something. And 3n by 4 gives you 83 into 3 by 4. 62.1. So we look for the frequencies which are just greater than 20.7. So 20.7 just greater than is this way. I'm in this class. Where do you expect the quartile 1? So your first quartile, this is your class, and 62.1, which is just by 0.1 we are going for the next class. So this gives you the quartile 3 class. So let me calculate both of them. So quartile 1 along with, the lower limit of this class quartile 1 is 10 plus the index what I have calculated is 20.75 minus the previous cumulative frequency is 18 divided by the regular frequency is 19 into the class gives me 10. And then for quartile 3, let me do the substitution. The limit is 30. Calculated cumulative is 62.25. Previous frequency is 62. The regular frequency is 10. The width is 10. Okay. So quartile 3 calculation looks simpler. 62.25 minus 62 gives you 0.25, and this 10 and this 10 gets cancelled. So this gives you 30.25. Very much near to 30. So value of quartile 3 we have got just at the beginning of this class. Just it is as well as 30, only 0.25 it is deviated from 30. Then from quartile 1, let me calculate. So this gives you 10 11.4 is will be the quartile 1 value. The quartile 3 we have got 30.25 and quartile 1 is 11.4. Then the quartile deviation is quartile 3 minus quartile 1 divided by 2. So this gives you 30.25 minus 11.4 divided by 2. So this gives you the quartile deviation. So this gives you 14.425. This is the value of quartile deviation calculated. So by looking at this frequencies, we have 18, 19 and then 25. Then there is a sudden drop of 10 and then there is an increase of 11. So the frequency pattern, though it is normal, but it starts with the higher frequencies and then this way the frequency pattern is. So it is not completely normal, but then again the first three classes contribute more to the entire distribution, and there is where we have the quartile 1. And then quartile 3 we have at the later class. But then again quartile 3, though it is in the next class, it is very much near to the lower limit of that class. So quartile 1 and quartile 3 are getting deviated as per the classes. We have classes as per the frequencies on the either side. So quartile 1 and 3 also changes their position depending on the frequencies on their both the sides. Okay, so then this is the calculation. We have calculated the value of quartile deviation. We will also calculate the coefficient of quartile deviation. So the quartile deviation, we have got these two values of quartile 3 and 1. So 30.25 minus 11.4 divided by 2. So this gives you 9.42. This will be the value of quartile deviation. So quartile deviation here gives you the value of 9.42, and then we have to calculate the coefficient of quartile deviation. So the coefficient of quartile deviation we have calculated is 0.45. So these are the values we have calculated. Quartile deviation is 9.42 and the coefficient is 0.45. Now if you study the frequency pattern again, so this frequency pattern is this way: 18, 19, 25, 10, 11. So it goes on increasing, then the maximum value decreases and increases for a little again at the end. So it is not the pattern which is exactly normally curved. It is a pattern with a little fluctuation at the end. Even this fluctuation disturbs the values of quartile 1 and 3. So ultimately what happens is quartile 1 and 3 are placed due to their frequencies on their both the sides and also due to the concentration at one particular point. So quartile 1 and 3 altogether can give you the scale in which the items are distributed or the range in which the items are distributed. So quartile 1 and 3, the deviation of quartiles, that is Q3 minus Q1 by 2, indirectly tells you again the range in which the most of the items are dispersed in the entire distribution. So then, but it is much better than range because it tells you the part where most of the items are dense or concentrated in the entire distribution. This is how the quartile deviation helps to understand. So there are few more measures to understand this distribution in the better way, to understand the dispersion of the distribution in the better way. So those measures will be covered in the next coming classes. So till then, so that's all for this video. So we'll go for the next concept in the coming video. So we'll meet in the next video with the new concepts. Till then, take care of yourself. Keep studying well. Thank you.